Awesome. Good morning, everyone. Nice to see you all joining here to talk about canola diseases once again. This was something that was a main topic yesterday, caught any of the agronomy panels or canola agronomy panels, so it's definitely coming top of mind. We've got a short amount of time, get through quite a few different slides and information around Verticillium. If I can get this to go. Got no life in the clicker. Where's my tech? Yeah, our tech. There we go. Now we got some life. It's on. It's working. So today I'm just going to cover a little bit on the basics, but really get into the big questions that I know bulk of you want to know about, which is really yield and what we can actually do about this disease. My background was with Canola Council, focusing on integrated pest management, so mainly on blackleg, but then eventually Verticillium. And now in my role with BrettYoung Seeds, I get to work with a bunch of different plant breeders and work with retail agronomists, farmers still, so kind of every different chunk along the production chain to try to find solutions to our biggest issues, and Verticillium has now become one of those. So in a unique position that way that I do get to work with the entire industry and try to find some solutions. So to cover what is the issue? What are we talking about? It's always good to go back to your basic pathology, and I know this can be a little dry. It's going back to university and breaking down what the pathogen and disease is, but it's really important to know the difference between these two things. So what we are talking today is the fungal pathogen Verticillium longisporum. Verticillium is a new disease or new pathogen here to Canada. It was first identified in 2014, but it has been identified in many other production regions. So it's not just a Canadian-specific pathogen, it's found over in Europe. And when we look at Verticillium species, they're broad-ranging. So they'll affect trees, they'll affect other crops, so it's not just a canola issue, but Verticillium longisporum is very specific to brassicae. And so what happens is it is a soil-borne disease. So it lingers in the soil and is then taken up by the plants. And there it goes up through the xylem. So it starts to kind of plug it up. So it's transferred through the xylem up into the stem. And that's where we start to get the actual disease. So that is Verticillium stripe. The disease here in Canada expresses itself as a half-stem senescence, a stem striping disease. And what happens is that it starts to shred and becomes very fragile. That pathogen starts to colonize. It causes the disease to spread and cause plants to start to lodge and eventual yield loss. And where we see a lot of issues with this particular disease is when we go to harvest the crop. It is a late season disease, it comes in late, and it really causes just harvest complications as those plants wrap around the reel. So that just is our basic to kind of set the stage of what we're working with. Next is just a rough timeline. So I'd mentioned this was first originally found here in Manitoba in 2014 on a farm just south of Winnipeg. That was the first isolation of Verticillium longisporum. Since then, we've been able to find it all across Canada. So the Canadian Food Inspections Agency did a wide covering survey. They were able to find it across the provinces. As we move along time, there were some changes in names. Typically, verticilliums are wilting diseases, so they cause plants to show wilting and die back that way. But what we see in canola, and saying we see it in canola here, we see it in canola in Europe, is it causes us more of this striping. So there was a name change there. Jump forward into the 2018, 2019, we had some delayed harvests. And what happened in those years is we really saw the symptoms pop up from there. We had lots of complications. Harvest was really drug out. We were taking off canola, late September into October, and it just become that much more noticeable. 2018 was also the first year that there was any sort of research funded here in Canada on Verticillium longisporum. And typically, if you're familiar with research projects and that whole system, they take anywhere from 3 to 5+ years. So we just had some of those projects wrapped up. But jump into 2020, we all remember what happened that year. There was kind of a lag in any sort of research or any sort of field work. And then the last few years, we've been able to survey and find it in more and more fields. We see it across the prairies. Saskatchewan's now got more fields popping up, and also into Alberta. You'll also note one thing is that we do see some claims of tolerance or resistant varieties on the marketplace. So in a short period of time, over a 10-year period, we've had a lot of effort and resources put towards this and understanding it. And so some of those resources that have come available are, like I said, we're starting from square one on this. We're just looking at the disease cycle. How does this pathogen affect canola, and at what rates? How does it taken up? These were all questions we really had not a clue about 10 years ago. So the efforts were on that. I'm not going to go into the specifics of the disease cycle. Just, it's a great resource. It's online. You can find it at the Canola Council webpage. But it really captures what we need to be IDing and maybe how difficult it is to find this in the field and how it changes. Soil-borne pathogen being the key part, late season disease, so you got to look for it later on. Some of the field characteristics and why we've seen it really take off in here in Manitoba is we've got the right conditions for it to thrive in. When we look at soil temperatures, for it, because it is soil-borne, to move in the soil, it needs temperatures above 15 degrees. What's our recommendation for seeding canola? 8 to 10 degrees, right? So right after the canola goes in the ground, the temperatures are ideal for this pathogen to start seeking out those root hairs as they start developing. As we move on, it's pretty easy to get air temperatures over 23 degrees. And then it really thrives in hot, dry. So as soon as we get those warm or those dry conditions into August, that's where that disease really sets in and becomes visible to see. And if we look at the past few years, we've been in a drought. We've had those really warm Augusts, and the pathogen has really been able to spread up into the stems. New work out of the University of Alberta was also just looking at soil pH. So typically in here in Manitoba, we do have a higher pH. They were finding that the pathogen really thrived and caused more severe symptoms with pHs above 7.4. So this is a really key component, because when we think about different pathogen like clubroot, it likes the reverse. So now we've got these two other ones. This may be a reason why we don't see really severe cases in Alberta yet. They typically have lower pH soils. So these are all just kind of key components, and there's been a lot of effort put into just understanding this pathogen. We are starting from square one. So in our audience today, I guess just raise of hands, how many are agronomists? I say bulk. How many are farmers? Okay. How many of you can confidently go into the field and identify verticillium in the fall? Not as many hands go up. So we're still really at that stage of learning and properly identifying it at the field level. So as of right now, images, field work, getting in there, trying to ID it. This is really what we've been working on. And it doesn't seem like a lot, but this is a really key piece. You need to know what you're working with before you can deploy any sort of management practices, before you can put a yield loss number to it. So just different examples, and it looks very, very similar to other diseases. Blackleg being one of the ones it's really confused with. I'll move through these pretty quick, but they're all visuals. There's lots of resources online comparing them. If you swing by the Canola Council and Manitoba Canola Growers booth, there's a resource there that's outlining all of this. Something like sclerotinia and verticillium look very, very similar. They both cause that very fragile bleached stems, and only if you peel back that outer stem wall will you see the mycosclerotia of verticillium. That is the key diagnostic sign of the pathogen and of the disease. Late season, another timing aspect. This is the best time to look for it, later in the fall, post-harvest, because the symptoms are then just that much more visible. The stems are extremely gray and very fragile, and they'll reveal all of the mycosclerotia. So once you finally figure out to train the eye what you're looking for, then this is what we see. We end up finding plants that are colonized by several pathogens. And this just really complicates matters, makes any sort of ratings quite difficult, and especially when we go to yield loss, trying to find those numbers is extremely, it makes it just challenging, complicated. So in Manitoba, so we know what we're looking for now. That's super key. Now it's trying to quantify how bad is it, where is it in the province and at what levels. So Manitoba Agriculture does a really great canola disease survey. It's been going on for many, many years. And they're able to go in and rate different diseases, canola diseases, for their prevalence, so just the presence of the pathogen or the disease in that field, but then also the incidence, the number of plants infected, and then severity. So you can see the first one here is sclerotinia. We've got an 8-year period. Over time, sclerotinia is really environmentally dependent. So if we have any sort of moisture coming into flowering, that is going to really dictate the pressure of sclerotinia. So you can see the difference there in the number of fields infected. So we move to something to like blackleg. It is very it's there. I'll just say that. It's there. It's in every field, but it's at low levels. And so you can pretty well walk into any field in Manitoba and find at least one plant showing blackleg. And then lastly, Verticillium. So you can see the numbers of Verticillium have really increased. In 2024, the number of fields was over 60. So 60% of fields surveyed had Verticillium within them. That number is likely even higher depending on when you would actually go back and follow up on some of these fields. The symptoms would have probably come through. But also earlier on in 2017, we didn't know what we're looking for. So not to say the level was, or definitely wasn't that low, but we weren't sure what to be looking for and how to quantify that. So you can see there's been a really big increase there. This year for incidence, this is the alarming number. So sclerotinia, yeah, we had the conditions, but we didn't really get a lot of plants infected per field, so it was only around 8%. Blackleg always sits in that kind of 10 to 15% of the number of plants in the field showing the disease. But the alarming number here is Verticillium. So in these 60% fields that are showing it, it's at a higher incidence rate. So there's over 32% of field samples showing up with the disease. So it's there, it's prevalent, we find it widespread across a field, which is a really alarming number. And so that's one of the kind of the key components there is it is there and likely aggressive. We are still missing severity data. So yes, it's there, but what level of impact is it actually having on the crop? So that really is the missing link when we go to talk about something like yield losses. So last year, the last few years really, we've had some pretty disappointing canola yields. Our provincial average was 37, the prairie average, our Canadian average was 36 bushels an acre. This is down, almost 10 bushels from some of Manitoba's record yields. And last year, a lot of the yield was being lost or contributed to being lost from heat stress, drought across southern Saskatchewan, Alberta, blackleg in Alberta and across the prairies really, and then Verticillium here in Manitoba. And these are just suggestions, right? There's nothing to really validate that those were the primary losses. Those are generalizations. So when we look to yield losses for Verticillium, we don't have a good answer. No one really actually knows what the losses are. So in Europe, a lot of our research here, a lot of the work we've been doing is based on European literature because they've been working with the disease and the pathogen much longer than we have. It sets a bit of a grim stage, and I throw up this one headliner. They call it the invincible threat for oilseed rape. So it is there. They've had it for years. How European farmers deal with it, they do grow winter canola, so it's in there much longer. They actually kind of see it as a positive or try to spin it as a positive. It's a kind of a natural dry down product for them. So it takes away any sort of green stems and helps with harvestability. But when we look at the literature and what we're showing, we see a wide range in yield loss numbers. So some of the early work was showing anywhere from like a 30 to 50% yield reduction when we were seeing Mycosclerotia present, which does take time for them to develop. Some of the other work done in Sweden, there was a range of 10 to 50%. In that same paper, they even widened it based on the inoculation technique and saw 20 to 80% losses. So just wild ranges when we think about what the actual loss is in a field. Work out of the UK was showing really inconsistent or insignificant, they called it, and they related that back to the weather. Verticillium is like sclerotinia in that regard, where it's going to be environmentally dependent. Some of our early Canadian work was just working in the greenhouse, trying to figure out how best to inoculate and work with this pathogen. We see some pretty high ranges as well, right? 63 to 80%. And that's one key piece is when we start to look through the literature, a lot of researchers express their complaints or their concerns of working with this pathogen. It is not a friendly one to work with indoors. So the symptoms are very different when they're working in a greenhouse or lab setting versus what they're seeing at the field level. So that makes me question a lot of the yield work. You know, if it's actually done in the field, okay, that would might be a little closer to what we're seeing, but it will kind of complicate matters. So we still don't have a great number. Here in Manitoba, we really have to just base it all on anecdotes. I've captured this over the last probably 6-7 years, just different comments. One of these first comments come from me, it was actually probably 7 years ago now. A previous colleague said it was the largest yield robber in the Red River Valley, and really was holding back canola growers in that region. And that's 7 years ago now. When we jump forward, look at 2024, growers are expressing it was so intense that they figure they won't be able to grow canola in future years. That's just how they figured it was just that devastating to their crop. Others throw in the 10 to 15% yield loss. That number can easily change to 10 to 15 bushels, right? It just really is variable. I'll have the other comment of, hey, you know, we saw it all across the field, but it still yielded 55. So 20 bushels higher than the provincial average. Like, why am I worried about this? And some of the work I've seen in small plots, just trying to pull some numbers, we would see kind of in that 5 to 9 bushels an acre on susceptible products. So there's a lot of numbers there, there's a lot of unknowns yet, and we haven't been able to dial in exactly what that number would be. But I think we can all agree there are some level of losses that we are definitely seeing from this disease. And so in 10 years, it's probably only been the last 5 years that this disease has been taken seriously, where there's been investment into research, there's been more focused effort, there's breeding programs now working with it. Just to throw some screenshots of just the importance and as an industry, and obviously if you're here today, you feel the same way. Canola Council's agronomist survey was done last summer, and it really focused here in Manitoba. Growers were really worried about disease concerns, and Verticillium kept coming up. Probably didn't help that I filled out that survey as well, but that is a key piece there. Manitoba canola growers, right now on their research priorities, Verticillium is right behind flea beetles. It has moved up in that ranking of importance. And then poll from yesterday's panel discussion here, the audience, this was polling the audience members, Verticillium was the number one concern that they wanted industry labeling for. So we are, I guess, all on board now and really trying to push forward on finding some solutions. So with that, so losses are variable, so what can we actually do at the field level? And I really, typically when I give any sort of disease talk, I would list off a nice fancy table or list of best management practices, but I'm not at a point of feeling super confident on doing that yet. We don't have enough work to confirm. A lot of this is just going off of anecdotes and field experience and learning from other diseases. So I am going to walk through a few potential options or things that we need to clarify before we really move forward. But it all comes back to that overall integrated pest management, and there might not be much we can do with Verticillium today, but the other diseases that are also in your field, there's a whole host of options to manage those. So if we can get those in check, hopefully we've got healthier plants overall. The one key point, I didn't put a slide for it, is there are no fungicides, there's no nothing you can spray to the soil or on that plant that is going to protect from Verticillium right now. It is a soil-borne disease, so spraying the plant above ground is not going to make a difference. Every integrated pest management approach, technique, plan has crop rotation, and especially when we're speaking in regards to plant pathogens, plant diseases. So this is a chaotic map. I don't know why Ag Canada makes it all these neutral tones, but this is the crop or annual crop inventory from 2023. The palish green color, which is predominantly all of this, is canola. Like, that is the sheer number of canola acres that we grow here in Manitoba. You can see Brandon and Winnipeg are the blurbs on there. You can see the different areas. There's some corn acres, there's the potato acres around Carberry, but it's pretty hard to go anywhere within Manitoba and not see a canola field within a 2-mile radius. So something like crop rotation is going to help in many other diseases, and I do highlight that, but it's not going to help specifically with Verticillium because this is a soil-borne, wind-moving pathogen, and we are cutting it right through the inoculum source and spreading it. And that is likely why we have no problem finding it all across Manitoba. It is there, it is prevalent. However, there are other diseases, and the crop rotation aspect is going to help minimize their pressure in those fields. Inoculum diseases that build up like blackleg and clubroot. There's research to show 2 to 3 years out of canola reduces those inoculum loads significantly. Something like seedling diseases, right? It's that overall plant health. So yes, it might not, help Verticillium, but it's going to help on a lot of other aspects, which are going to help overall develop this healthier plant that can hopefully fight off Verticillium. Weed management's thrown in there as well. That's your green bridge. So anytime you have canola volunteers, right, they're just going to keep housing that pathogen. Any other brassica plants, they're also hosts for this disease as well. This is an interesting one. There is no work to validate this right now. This is all just field speculation. When we look at a disease life cycle and understand Verticillium, what could be done. But one of the components that's been brought up is straight cutting canola. And what happens when we straight cut canola versus our traditional ways of swathing? We allow the pathogen to move up into the stem and cause further infection. So those straight cut acres are left out another month, 2 to 3 weeks, however long. That's allowing that pathogen in there to colonize and spread and create further infection up in that stem. From there, you're going to cut it right through the inoculum source. It's going to spread over the combine. It's going to go up into the wind. It's going to blow to your neighbor's field and cover your entire field. So this is an interesting one. The idea here is that when you go to swath canola, you're cutting those plants before the pathogen has been really able to get up into that stem and cause further disease. So this is one I'm really curious to see some work and some trials on. Manitoba Canola Growers is aiming to use this as one of their on-farm trials next season. So be very curious to see the results and if there is a significant reduction in overall inoculum, but also increasing your yields. So it's all tentative. This is the one I think where people have got the most interest in. This is one that I get to work with on a daily basis, is working with plant breeders for developing resistant hybrids. So we obviously use these in things like clubroot, for fusarium wilt, and for blackleg. But some of the challenges that are out there right now, because we're starting from pretty ground zero with working with this disease here, we have no standardized disease severity scale. So companies right now are using whatever means they want. Researchers as well, if it's a 0 to 9 scale, a 1 to 5, whatever. We're all using something different right now. So what my concern is there is when we come to a marketable product, there's no consistency in the messaging. And we've seen these issues with stuff like clubroot as well. Quantification of yield losses, so we still don't know what that yield loss number looks like, to then actually put a scale into place to say, hey, if you're a rating of 3, that's a good thing or a bad thing. How much loss is associated with that? Because companies are using this for field testing and deploying products in the field and making their ratings, there's a huge variability in inoculum. So you're going to have skewed ratings that way. One other component that we have noted, and I've seen this in retail trials, is, that product looks really bad for Verticillium. It's the earliest product in the trial. And so that's another key piece, and this is what that graph is showing, is early products are going to dry down quicker than the rest, and so they will be rated just human error harder for Verticillium, so they look worse off. And just overall, okay, we might have some traits, we're working with things, we can see it, we don't have a really good understanding of that host defense mechanism. How is that plant fighting it off? What are those resistance traits actually doing? So understanding the host pathogen relationship needs to be clarified. So on a positive note, and I'm trying to pull some positivity out of this, there are definitely products on the market today that have levels of tolerance to Verticillium. companies just aren't all at the same point of rating them because of all of those previous concerns I just mentioned. But this is just an example of a hybrid. We can see it at 2 different locations and at 3 different timings, and you can see its progression and how bad it is. So this is a product that's never going to hit the marketplace because of this. We know for sure it's Verticillium, it's going down. If you note the products next to it, they're standing, they're green, they're looking perfectly fine. Verticillium's not an issue. Okay, and my last slide is just overall breeding for canola hybrids. This is extremely challenging. It does not just happen overnight. So we are working with this disease for the last 10 years, roughly, right? And it takes a minimum 6 years alone once you actually have some of this established research put in place in a system to rate hybrids before that hybrid ever gets put into seed production. So it takes a lot of time. And looking at one of the polls yesterday, a grower is still basing bulk of their decisions on the yield and a pod shatter trait. So it's really tough for a breeding company to focus a lot of time and effort into some of these other pathogens or other concerns when they're not the end, or the product's not being sold by them in the end. There's a bunch of registration requirements. Canola hybrids need blackleg, they need a Verticillium wilt rating, the optional for clubroot. So there's a lot of other traits that need to be clarified first. And I just put out a quick warning when we look at something like clubroot. It was found in 2003, new hybrids 6-7 years afterwards. Within a 4-year period, they were overcome. So we don't want to run to the marketplace and not have these ironed out perfectly, because we want to provide a product that's going to have some longevity and help solve our answers to Verticillium. So my last slide, it's tough to summarize or to provide any sort of management practices. If you're coming here today, I'm sorry, that's not what I'm able to really provide. We are working on it. It is here. We know the Verticillium is here. It's widespread, and it's not going anywhere. It is here to stay. So learn how to identify it. I'll keep putting emphasis on that because bulk of us still can't do that. But if you have other diseases in that field, which you will, use those and clear up the management practices there to help increase your yield that way and create that overall healthier plant. I hesitate on using, obviously, resistance as our only mechanism to fight it. We see how quickly that can be overcome. So we need other management practices to support it. And the research is there now, it's happening, and hopefully within another couple of years we'll have clear answers for that. And that's the last note on collaboration. So as an industry, keep expressing your concerns. We need to hear it as an industry that this is an issue on your farm, and the research funds will start going that way. The breeding companies will put more effort on this. As of right now, this is still really a Manitoba issue, so Manitoba farmers need to have that voice and be voicing it on their concerns. So with that, thank you very much. We've got a minute to spare, but if you have any questions at all, please reach out, and I'd love to chat further on Verticillium with you. Thanks. Do have a question. Oh.
I'm good now.
Yeah.
I'm just wondering if you're seeing a correlation between late season lodging and the incidence of Verticillium.
So I don't have numbers to back that up, but that is definitely something, and especially on a small plot scale, that we do see. Those products that are high in incidence are really going down with lodging. And that's where it'd be nice to take that rating, a severity incidence rating, overall to make that type of decision with it. So there's not a good data set to support that, but that is the key symptom we are seeing with it is going down. Oh, hey, Chuck.
Morning, Justine. Just wondering, you're talking about the spores spreading from straight combining and things like that. Do we have any idea how far the spores can travel by the wind and other means? And also, how long do those spores stay viable in the soil?
Yeah, so great question, Chuck. So University of Alberta did do a little bit of wind movement work. it was really on prevalent winds, so this is likely why it's taking a little longer for it to creep into Saskatchewan, because it's working against the winds. But these will travel great distances, right? They're extremely tiny. Viability, some of the work in Europe has shown in that 10 to 15 year range. And that's really why when we think of something like crop rotation, we're not staying out of canola for that long. And you could be out of canola that long, but your neighbor's been growing canola, so they're blowing in. And that's really what has increased the level of an inoculum here within Manitoba, is just sheer amount of acres and across the province, or across the prairies really. But awesome. Okay. Thank you very much.